Good afternoon. Our speaker today is Dr. Ari Michelsen. Ari recently joined the staff at the Water Research Center as an Associate Director for Information Transfer. He also has a joint faculty appointment in the Department of Agricultural Economics. He received both his PhD and MS degrees in agricultural economics from Colorado State University. He has extensive experience in the consulting industry, working on a variety of issues related to water and other natural resources, energy, financing, and so forth. And is going to speak to us today about some of the work that he did for his doctoral dissertation concerning the potential for option contracts and water transfers to alleviate drought conditions in municipalities. Ari?
Thank you, Steve. I hope this is switched on. If we could turn the projector on, please, there. Thank you. As Steve mentioned, today's discussion is on the potential role of option contracts for solving urban drought water supply problems. Non-agricultural uses of water are increasing rapidly, such as industry, power plants, recreation and wildlife, and even agriculture. As these uses increase, the cost for water supply is increasing dramatically also. Agricultural water is being used as a supply for both growing demand and drought insurance by urban municipalities. Here we have an example of water supply originating in the mountains with an urban community growing and taking over agricultural water. There's quite a bit of water available throughout the West because agriculture consumes approximately 90% of the water even in urban areas. However, during drought conditions, water supplies are in short. Water in short supply. As you can see, this is a river in August, and basically there's very little flow in the river for urban agriculture or even in-stream flow uses such as wildlife. So that urban entities are turning towards agriculture for their drought water supply demands. This is a problem, and the reason why it's a problem is because purchasing water rights for drought insurance is costly. Now, it's costly because drought insurance supplies are infrequently used. Therefore, they're left idle in many years. Water rights purchased for drought insurance are also withdrawn from productive use, so that they're not being used either by the urban entity that buys them for drought insurance, and they're not available for agricultural purposes. Therefore, economic losses are incurred both by urban and agricultural users. Urban users pay a higher cost simply to purchase the water rights and hold on to them for drought that may only be used in 1 in 20, 1 in 30 years. And agricultural production is lost even though the water is available in most other years. An alternative has been proposed that would reduce the impacts and resolve some of these problems. And they're called water supply option contracts. A water supply option contract is basically an agreement between a farmer and an urban water user to transfer the water when needed during critical drought from agriculture to the urban user. This water is returned to the farmer during normal water supply conditions, and this means that the farmer can continue production during those 19 out of 20 years that the urban entity doesn't need the water. The farmer is compensated for the temporary transfer of water use. The water is taken from his land during that one drought year, but he's paid for that in terms of his value. The farmer also receives a payment as an incentive to hold an option contract, and this is above and beyond what he would normally get from agricultural production. The farmer retains ownership of the water right, and this is very important in terms of financing. Farmers find it difficult to go to the bank after they've sold their water right and try and rent it back on a year-to-year basis and borrow money for capital equipment that will last 10, 20, or 30 years. And urban users obtain drought water supply insurance at a lower cost because they're simply paying for that water during the years that they need it rather than buying the water right directly. Now, option contracts provide a mechanism that is currently missing in today's water markets, and they provide the mechanism to temporarily transfer the water from agriculture to urban uses. Now, typically agricultural uses are low-value uses, whereas urban uses are high-value uses. Option contracts may also be a lower cost method to supply drought water insurance. And this, as I mentioned earlier, is because the city is only paying for that water during the years that they use it. Agriculture users benefit from this type of arrangement because they're paid not only the option, in other words, for holding that option contract, but they're also paid for their production when that water is taken. And that production can be based on a number of factors that we'll go into later, but it may be more secure than trying to raise crops during a drought year. One thing needs to be noted: option contracts are strictly a concept right now that haven't been implemented. Two large companies, one the Metropolitan Water District of Southern California, which is the largest water provider in the world, and an electric utility, have explored option contracts. And the point that the reason why they have not been implemented to date is simply working out an agreement with a farmer of what is an appropriate payment for that production that's lost during the drought year. The objectives of my research were, one, to analyze the economic feasibility of water supply option contracts. Now, since this hasn't been done before, we needed to look at several factors. One, are option contracts feasible? And to do that, we had to identify the economic, institutional, hydrologic criteria that are required to develop water options. The second, we had to develop a method to value water supply option contracts. Are they better than purchasing water rights, which is the current method used to provide drought insurance? And three, we had to analyze the economic feasibility for a case study area. We wanted to look at a specific area and find out, are they reasonable, or should people simply go out and buy the water right and take it out of agricultural production? The factors that were looked at, or the criteria that were developed, are: one, you need identifiable and transferable property rights to have an option contract. And this criteria is met through most of the appropriation rights systems throughout the West, because water rights are identifiable, and in most states they are transferable. If not on a permanent basis, they may be transferable on a seasonal or temporary basis. You also have to have differential use values. One user, the value of water has to be higher to one user than the other, and this is also met. The value of water to the urban users is typically much higher than the value of water to agricultural users, and this is especially true when there's a drought. You also have to have infrequent or temporary demand for water by the higher valued user, and this is met. The urban user only needs that water during 1 out of 20 years, for example. You also have to, the agricultural user has to be able to suspend his operations during that year. Now, this will depend on the type of agricultural production. It can be done with most crops, including hay, which may only need to be irrigated once or can skip a season and still survive. However, it may be more difficult if you have contracts for your crops, such as malt barley, or you have livestock operations. You also need to have identifiable water use values, because you need to know what the value of that water is to the urban user, how much he's willing to pay, and you also need to know what the value is to the agricultural user, what you need to pay him to take his water for that year. The water supply must be reliable during drought. Well, this would occur whether you purchase the water or whether it's under an option contract. The urban entity needs to know, in that 1 in 50 or 1 in 100 scenario, is water going to be in that ditch system so that he can use it? You also need to know the drought probability and severity. How much water do I need, and how often am I going to use that? Supply option costs must be lower than the alternative water supply costs, and this simply means that the option contract, in order to be economically feasible, needs to be lower than alternative methods of water supply. This could mean building a dam, it could mean buying agricultural water, but it has to be lower than that in order for it to be feasible. Finally, and this has been a sticking point, option contract buyers and sellers must be willing to negotiate contract terms. How often are you going to take the water, and what is that water worth, and what are the payments going to be? These were developed into 6 evaluation factors necessary to evaluate option contracts. The probability of option exercise, how frequent is that drought going to occur? The option exercise cost, what is the payment to agricultural water users? The price of water rights, you need to know this because that's your supply alternative typically. You need to know what the water right price appreciation is, and that's how much that water right price is going to appreciate over the term of the option contract. The reason why you need to know that is if you don't buy that water right today, 20 years from now when the option contract expires, you're left with renewing the option or purchasing that water right. You need to know the interest or the discount rate. What is the money worth over that period that you may be saving money by not buying a water right? And you need to know the option contract length. Obviously, is it going to be a 20-year, 30-year, 40-year contract? These factors were put into an option evaluation equation that I developed. And what this equation does is it compares the water purchase cost with the option contract cost to give you the present value of what that option contract would be worth. Obviously, if that option contract value is negative in this case, the option contract is worth more to you than the water purchase cost. This equation takes into account the water right cost at time equals 0. That's what you would need to pay to purchase that water right, times the interest rate over time, plus the maintenance cost. Because when you purchase a water right, you are also incur annual assessment costs by a ditch company or to maintain the supply system, the storage reservoirs, the diversion system, etc. Typically, those costs are between $10 and $20 a year for most irrigation companies. Now, this is all discounted over the period of the option contract. What you're comparing this with is the option contract cost. And the cost of that option contract is the exercise cost times the probability of exercise. Are you going to exercise that contract once during the 20-year option contract period, twice, 3 times? And that's where the drought probability comes into the equation. And that's discounted over time. Plus, you need to know what the water right appreciation cost is. If you enter into an option contract, as I said, at the end of that 20 years, you need to know what would it cost me to go back and buy a water right? What have I lost? Has the water right price appreciated more rapidly than the option contract value? This present option value is the net benefit of those options. Now, that benefit will need to be split between an option contract payment for the farmer to hold the option, the benefits that the city receives, and the benefits the farmer receives. A case study area was selected to test out the feasibility of options in terms of hydrologic flow, the actual agricultural value, the value of water right prices. The case study area that was selected is in northeast Colorado, in this area, just north of Fort Collins. It's the Poudre Basin. Now, this basin covers several thousand square miles, and the irrigation company that was examined, as I said, is just north of Fort Collins. The water supply for this irrigation company and the supply for Fort Collins comes from the Poudre River, and this is along the Continental Divide. This water is stored in more than 65 reservoirs for just the North Poudre Irrigation Company. This one irrigation company supplies and irrigates 25% of the land within this river basin. This is just a photo of one of their reservoirs in the northwest part of the basin. They have several diversion structures on the main stem and on tributaries. This is a diversion structure constructed by the Bureau of Reclamation. A little bit later we'll see just how seriously water rights are and water right prices with a farmer at this irrigation structure. This is the other side of it. This is the main stem of the Poudre River, and that diversion gate will close and allow water to be diverted through an underground pipeline in the hill here. This is the same photo showing a little bit lower flow. The first flow that you saw here was during the '82 floods that we had, and this is some of the highest flows that we had over the last 100 years. This photo is more typically average flows, midsummer flows. This water is then diverted to approximately 25,000 acres of irrigated land. It may start from the head gates of some of these supply reservoirs. If you open up the head gate at 8 in the morning, it won't get down to some of these farms till the next day during the day. This is one of the ditch riders adjusting the head gates for the flow to the farmers. There are 4 crops that comprise approximately 95% of the acreage in here. Corn grain is about 55% of the total acreage grown in this irrigation district. Alfalfa is about 25%, and pinto beans and malt barley grown for Coors beer production is the rest. And the malt barley, as I mentioned, is one of the cases where option contracts may not work. These are highly valued contracts. You can't simply cease production one year and then supply malt barley the next year. The company needs that reliability of having the malt barley each year. A model system was developed that incorporates the drought conditions, the hydrology, the legal and institutional methods in the area, the deliveries to the agricultural areas, and how much water is consumed both by agricultural municipalities and industry. From this, I'm going to go to some overheads that will show you how water was valued and how the allocations were derived. The first part of the model was a river basin flow and drought study that was done for the area, and this was done for the city of Fort Collins. The original data was 500 years of drought, in the drought study of 500 years of flow data for the basin, and this was developed into a stochastic model that was run for a 50,000 year period, so that they were able to develop flows over time and look at what a 1 in 20, what a 1 in 50, and what a 1 in 100 drought period would be. What they basically found from looking at the historical data is the occurrences were random, so that you couldn't really tell from one year to the next what they were. And this was put into a hydrologic, whoops, if we could go back to the, thank you, hydrologic allocation model. And that model allocated water based on the legal and hydrologic restrictions of the basin. How much the reservoirs could hold, what the water deliveries were from the reservoirs and the canals, and what the legal priority system was. These values were then put into an economic water valuation model. This is where the agricultural water values were developed. What is the water worth to the farmer, and how much water is available to him? And finally, these were put into the option valuation equation that you saw a little bit earlier. Could we go? Thank you. This is a plot simply demonstrating 500 years of the hydrologic drought flow study. And as you can see, you have very high years and some very low years. From this, we had to identify what a drought period was going to be identified as and which periods we were going to use for the study. And 3 periods were selected. And they were based on, it's a little bit small print here, but they were based on the duration. That's how many years did the drought continue for, what the severity of the drought was, how far below normal conditions there were, and the total cumulative drought shortage. And that's the amount over the whatever period of years that you have that are sequential years below normal. And here you can see, for example, a 2-year drought. This is approximately a, 6-year, 8-year drought. And this is a 6-year drought. This shows a much larger overall shortage over the period. Now, typically with the reservoir systems throughout the West, you can sustain supplies over 1 or 2 years of drought period, but when you start reaching 3 or more years, you've drained your reservoirs and you're relying simply on those stream flows during those periods. And that's when cities and other areas really need to have that drought insurance. Could we go back to the overhead, please? Or thank you. The drought characteristics that were identified for this basin and used for this evaluation were 3: a 1 in 20 occurrence, a 1 in 50 occurrence, and a 1 in 100 occurrence. The duration for these, as you can see, is 3, 6, and 8 years, and it shows the annual river basin shortage, which is the shortage from normal conditions for each of those periods. And you can actually see that the 1 in 50 drought occurrence has a slightly more severe annual shortage than even the 1 in 100. However, the cumulative shortage for the 1 in 100 is much more. And that's the shortage that you would sustain over that entire drought period. The annual average river flow for this basin for the virgin flows is 288,000 acre-feet. There is also a significant amount of water imported from the west slope in the Colorado River Basin. Could we stay with the overhead, please? Thank you. A network hydrologic simulation model was used with those flows for each year and the diversions to determine how much water was available to the city, to the irrigation companies, and to industry. This model was able to predict flows that were within 1% of the average conditions and within 5% of the drought conditions. So the flows were very close to what we've seen historically for the various conditions. This doesn't necessarily mean that we'll always have the historical simulation, but it does indicate that under current operating conditions, the model was quite accurate. The stochastic drought model was this first component of the Poudre Basin flow. I just showed you the network diagram of the hydrologic simulation and institutional model, and those gave us the, after they were adjusted, the storage, evaporation, conveyance losses, and deliveries to municipalities, industry, and agriculture. The amount of water available for agriculture was then put into a linear program which used crop enterprise budgets. Consumptive use requirements for each of those crops in this region varied for the water supply conditions. Irrigation efficiencies, and most of this is surface irrigation or furrow irrigation. The crop distribution and a range of crop distributions within the area. The yields that have been observed within the past 7 to 10 years. We looked at a longer range, but yields have been increasing significantly. And crop prices, and the crop prices that were used were an average of the past 7 years. Crop prices, as I'll show you, have been declining. Two types of water values were estimated in this linear program. A long-run value, which is the value to the farmer if he were to sell the water and simply get out of farming, and a short-run value to the farmer. Now, the short-run values will typically be much higher because the farmer has to cover annual capital costs that would not need to be covered with a long-run value. Well, we can't get quite all of this. Oh. The linear program was run for a range of water supply conditions. The average water supply available for agriculture was about 47,000 acre-feet, slightly under. And the agricultural value for that in the short run was about $82 an acre-foot. So in other words, if you wanted to compensate the farmer for the value of his water, if you're going to take it during an average year, it would be about $82 an acre-foot. As you reduce water supplies, that farmer will be changing his management methods, but will also be cutting back to more valuable crops. The typical 1 in 20 drought conditions, the water was worth about $90 an acre-foot, and that's up here on this curve. So that as you reduce the water supply, the value of that water to the farmer is increasing. He's cutting back on possibly his low-value crops that he can't afford to irrigate, and staying with corn, which is a relatively high-value crop as you move up this curve. We looked at a number of different crop prices, as I mentioned, for this. And one of the reasons why we use the last 7 years is, as you can see, the long-term or 40-year trend in crop prices has been continually declining. Now, when you enter into an option contract that say 20 years, you want to give the farmer a fair value. That fair value, we felt, was within the range of more recent prices. However, it can be adjusted within the contract for current market conditions. If there's a national drought or if world markets change, then you'd have to pay the farmer for whatever value his crop was worth at that time. This table shows a range of both water conditions and crop prices. Now, these are the prices that you would need to pay that farmer when you exercise the option contract. During average conditions, you can see that the value of water to the farmer in this area was worth about $85 an acre foot. Now, that, again, that's the short run value. It's less to him when he can divest himself of some of the capital improvements. As you increase the drought conditions, that value increases. I'm sorry, the value increases to $92 an acre foot. So within water supply conditions, the value of that water is not very wide, ranging from $82 to $92 a foot isn't quite as wide of a range. However, when you start looking at differences in crop prices, you can see a much wider range. Again, looking at average water supply conditions, if the crop price is low, that water may only be worth $40 an acre foot. If the crop price is high, which is the maximum that we've seen over the last 10 years, then that water value may be as high as $123 an acre foot. Now, these are the payments that were put into the option value equation to determine or to estimate the feasibility of option values and their net present value. I'm going to go back to some slides now. If we could. One of the other factors that's required to evaluate the feasibility of option contracts is the price of water. I put this slide in to indicate that water rights are definitely taken seriously out west. This is the same diversion structure, and this is a farmer within the irrigation company. There was a dispute between the Bureau of Reclamation, which was operating the diversion structure, and the farmer, and he went up there, and you can see the shotgun on the hood, and invited the Bureau of Reclamation to come up and discuss the problem with him. They are taken very seriously throughout the West. Two of the factors that are required to analyze option contracts are the price of the water right, as I mentioned, and the water right appreciation. Now, this slide shows the historical water right prices in northern Colorado, both for the North Poudre Irrigation Company and Colorado Big Thompson water rights, which are very secure water rights and much more transferable than others. And that's why the price between the two is different. These are the North Poudre Irrigation Company water rights in red and Colorado Big Thompson water rights. Now, there was a big spike in the late 70s with a lot of water right speculation. Prices have come down and they've stayed down the last several years. And when you start looking at the long-term trend, it's approximately 1 to 3% increase in water right prices over the last 20 to 25 years. These water right prices are some of the best established prices in the world. And that's simply because northern Colorado has one of the most well-developed water markets in the world. Rights are exchanged frequently, and you have a pretty good idea of what their value is on the market. What we're looking at currently, if you go out and consider, am I going to buy a water right or am I going to sign an option contract, are prices for North Poudre Irrigation Company in the area of $600 an acre foot. What you would look at 20 years from now at that 1 to 3% water right price appreciation are water right prices in the area of $900 an acre foot, or a 50% increase in water right prices. From the information developed from the hydrologic and drought simulation models, the agricultural valuation model, and looking at water right prices, these are the baseline conditions that were used in the valuation equation. What we started out with was a drought probability and severity of 1 in 20, and that simply means you would expect to exercise that option just once out of the 20-year contract. Option exercise costs, or the value that you would need to pay the farmer, of approximately $90 per acre foot. And again, this is assuming the average crop prices in a 1 in 20 drought water condition. A water right purchase cost, and that's your alternative, of $600 per acre foot. A water right price appreciation, and that's, we use the mid-range there, and that's about 2% appreciation per year. And when you compound that, that's approximately a 50% appreciation over the 20-year contract. A water right management cost of $12 per acre foot. That's your maintenance or your assessment cost that you need to pay when you buy a water right. A real interest rate of approximately 4% per year. Now this can be compared to current rates of about 9% if you assume 5% inflation per year. And a contract length of about 20 years. The result is that option contracts over a range of water right price appreciations and discount rates are beneficial and do show high net present values. This table shows both the option contract values over 4, 6, and 8% discount rates and water right appreciation rates from 0 to 5% per year. Now 5% is a pretty steep rate, although that could occur during some years of speculation. What we have for the baseline conditions are that water right, water option contracts show a $300 per acre foot or $295 per acre foot net present value benefit. And that's the benefit to both the city and to the farmer. That payment would need to be split between the two. But that's over purchasing a water right. So for example, if you went out and you wanted to buy 100 or 1,000 acre feet, for each acre foot of water that you option instead of purchase, you're saving almost $300. As you see, it's quite sensitive to the discount rate. As you increase your loan payment for purchasing the water right today, you increase the benefits of using an option contract versus buying water. It's also quite sensitive to water right appreciation rates. As water rights prices rise more rapidly, the value of option contracts decreases. And it's only when you get to about the 5% range, even at a 4% discount rate, that it pays you to buy the water right versus entering into an option contract. I ran several sensitivity analyses for these. One is what happens when the water right purchase cost changes. As I showed you, water rights for the North Poudre Irrigation Company were selling for about $600 an acre foot. However, when you move down along the Front Range to Denver, water right prices are selling for approximately $3,000 an acre foot for agricultural rights, and new projects may be running anywhere from $4,000 to $10,000 an acre foot. As you increase the water right purchase cost, that's your alternative from using an option contract, you increase the benefits of an option contract. The more you save if you enter into an option contract versus buying a water right. And the benefits increase quite dramatically. Again, using the 4% discount rate, if you increase to 1,000, you're saving more than $400 over that period of the contract per acre foot. If you look at $4,000 an acre foot, which they're looking at at a minimum cost for new development projects, you're saving almost $1,400 an acre foot. I also looked at the range of agricultural water values. How much do you have to pay the farmer, and what impact does that have on the value of an option contract? Again, the $90 per acre foot is an average for 1 in 20 year conditions. Now, that if you look at changing the value of the payment based on higher crop prices, we had a maximum of $135 per acre foot. Well, even when you look at that maximum, option contract benefits still show a $260 net present benefit. That means it still pays you to use an option contract, even if you have to pay the farmer $135 an acre foot. Now, typically, for the crops that we were looking at, a farmer will apply 2 to 3 acre foot per acre of land. So you're paying that farmer, say, $270 to more than $350 per acre of land that he has not to grow crops on it that year. That's sufficient to pay him for the value of his crop, the profits that he would have received. It's also sufficient to pay the farmer for the loans on the capital equipment, his machinery, his taxes, his management effort, etc., so that he can actually survive during that year that the water is taken. The last item I looked at is what happens if you exercise that option contract more frequently than you plan or less frequently than you plan. And option contracts are actually quite insensitive to this. If you exercise it twice as often as you plan, or a 1 in 10-year drought probability, it goes from $295 down to about $230 benefit for having that option contract per acre foot. If you exercise it much less frequently, you go from $295 to $340 an acre foot. And this means that there's approximately a 5% chance that you'll exercise it during that period of the 20-year option contract. Benefits, as I showed earlier, increase significantly if we're looking at higher interest rates in the market. And that's the rate that you would have to put down and either pay or could earn interest on for purchasing that water right. The conclusions of this research show, one, that the basic criteria required to develop option markets already exist. You can transfer water in most cases. There are water values. Urban entities value water higher than agricultural entities, and water supplies are available to transfer this water in most years and are legally transferable. Water supply option contracts, as I've just shown, are economically feasible, both over a wide range of economic and hydrologic conditions, but also a wide range of the agricultural market conditions. The factors that have the greatest influence on the option value are, one, the price of the water right. Are you going to pay $600 for the alternative or $4,000 for the alternative? The water right price appreciation, how fast is that price increasing over time? And the interest rate. How much you save by not purchasing that water right today. It's money that you don't have to go out and borrow, or money that you could use for other purposes. Factors that have the least influence on option values are the exercise cost, what you pay the farmer. Now, this is a surprising conclusion because most people, when they started looking at this, thought that that would be the primary factor. Well, it's not. The payment to the farmer is a minor factor, and water right option contracts, rather, are beneficial over the range of values of water that is worth the farmer. It's another question of what the farmer wants for his water, and that's a negotiating point. Another factor that did not have much influence on the option value was the probability of exercise. Do you exercise it once during the 20 years, twice, 3 times, 4 times, or less? And you could afford to exercise it 3 or 4 or 5 times even over that option contract period and still come out ahead with option contracts versus purchasing a water rate. This is also important because if your projections on how often you'll need that water are inaccurate, you have a lot of leeway. You can let the farmer know 6 months to a year in advance that you think you'll take the water, dry them up for a year, and not actually need the water, and you're still not going to, or you're still going to come ahead with an option contract. And the last is the time the option is exercised. We looked at exercising the option contract in the 1st year, in the 10th year, and the 20th year. And that didn't have much influence. It did have a little, because what you're looking at is, do you have to make an option payment up front, you know, when you've initially signed it? Do you have to make the option payment in the middle? Or can you save that money till the 20th year before you have a drought and have to pay the farmer? As I indicated earlier, the most significant problem that's anticipated in developing water option markets is the acceptance and negotiation of contract terms between water managers and farmers. There's a perception difficulty there of what farmers feel that their water is worth and what the city can pay. And this is a term that needs to be negotiated and has been the holding point between developing option contracts to date. In conclusion, whether you're dealing with agriculture or water rights, they're both a gamble. And we really need to look at how we're managing our water supplies and take into account alternative management methods. Thank you. Are there any questions? Yes, Dick.
It strikes me that this water supply contract strategy could be used to resolve other sorts of conflicts when you have competing users for the same water. Mm-hmm. The one that comes to mind right away is concerns the lawsuit that's going on right now between these same Colorado irrigators and the Forest Service. And I wondered if the Forest Service could take the place of an urban entity and buy you know, the water supply, or set up the water supply contracts in years when they would want to retain that water for channel maintenance flows. Is that some sort of a case where that would be applicable or not?
That's certainly a possibility. The problem that I could see with that, though, is that the Forest Service may not value the water highly enough to pay the agricultural user to make it worth transferring and drying up that land. You need a fairly large differential in order for it to be feasible. In the case of urban entities, as I indicated, cities are willing to pay $3,000 and $4,000, and a lot more than that in some cases, for that water right. Farmers typically can't afford to pay more than $500 to $1,000 with current crop prices for a water right. So you need a very large differential. If it's worth that much to the Forest Service, then it certainly would be an alternative that they could use. Typically, option contracts would be used by cities for domestic water supplies, as I mentioned, or electric utilities or other industries that need and value water very highly during those drought periods. Yes?
What constitutes a drought?
In this case, the drought was identified as sequential years of below average flow that met certain conditions, and the conditions that we used for this were typically a 1 in 20, a 1 in 50, or a 1 in 100 year drought probability. And those ranged anywhere from, I believe it was 300,000 acre-feet shortage within this area to almost a 700,000 foot shortage within this area. So they were identified based on hydrologic conditions.
Would these water options influence urban growth at all?
They shouldn't. Urban growth, if you're actually growing, you're going to need water every year. Water options meet the demand for drought insurance, where that water is not necessarily needed every year, and so that it can be used for two different types of production when there's sufficient water supply available. Yes?
Barry, then going back to the earlier question, the options, you know, in most agricultural options, you know, anything that's fungible like that's determined in the open market. This is, if the Forest Service, the market would not determine whether they could bid enough for that, or?
In a way, the market would. With Forest Service uses, you know, except for lumber, it's primarily non-market demands, and which means recreation or wildlife. And it's although those values are quite high, it's difficult to translate that into a minimum flow that the Forest Service can justify for a specified dollar amount. Those are typically, and as we see in Colorado, are being handled more through the courts rather than through an economic market system. Any other questions? Yes.
I was wondering how sensitive the value that the city could afford to pay was based on the proximity of the water right that would then be not used, whether you took into account the difficulty of getting the actual water to the storage supply or the treatment plant for the city.
That's an additional cost that would be incurred whether you were optioning water or buying the water right from the entity. Obviously, you've got to compare apples and apples with that. But if you're looking at buying a water right from an irrigation or from an agricultural use, you've still got to find a way to deliver that water to the city. In the case study that I chose, the North Poudre Irrigation Company was adjacent to the city of Fort Collins, and the diversion systems are in place so that they can use that water. In fact, the city owns a significant share of the company to date, so that they are able to use that water. One of the questions that comes up more frequently that I think is related to that is how much water can you transfer? Because typically you have to take into account consumptive use, and that's the only amount that's transferable. Now, in several states, you're allowed to transfer all of the water on a seasonal basis rather than taking into account consumptive use. That's doesn't always agree with some of the laws, but it means that if 2 acre-feet of water are being used on an acre of agricultural land, during that one seasonal transfer, you can transfer 2 acre-feet. More typically, when you buy a water right, you're looking at buying 2 acre-feet Only 50% is consumptively used. The other 50% is return flow, which you cannot transfer to the city. So you have to buy 2 acre-feet of water through a water rate purchase to only get 1 acre-foot of water.
Do you run into any, what you expect, legal problems, and the water rights usually specify the usage?
If it's tied to the land, you certainly could. Is that what you're indicating, or? Yeah. In some states, that could be difficult if you're not able to transfer it from the land. Although, as I indicated, in the states that we were looking at, primarily Colorado, Arizona, California, Utah, you are able to transfer that water, particularly on a temporary basis. If it's not a permanent transfer, the regulations tend to be much more flexible. It also helps if the city's within the irrigation district, because then you don't run into a lot of the return flow and other legal issues associated, so that you can transfer typically all of the water. And cities have a lower consumptive use than agriculture, so you end up with a higher return flow when you do transfer to the city. Any other questions?
Were there any consideration given to the effect of urban water use on water quality versus the agricultural use?
No, there weren't. However, options have been considered by a couple of cities now as a method to dilute effluent during low stream flows. So rather than actually consumptively using the water for domestic or industrial use, purchasing options to dilute stream flow to meet water quality standards. Well, thank you very much.